Going to be talking about an atom. So I'm sure you've heard this term which states that an atom is the smallest building block of matter. So you can compare this easily for easy clarification. You can compare this to a house which is built which is made up of many bricks, thousands of bricks, but then the smallest building blocks of that house, or the smallest building units of that house, is the bricks. Each single or each individual brick is the smallest building block of that certain house. So let's look at first the structure of an atom. So how do you identify that something is an atom? So there are certain models and signs that help you to identify. Just this one is an example of a model that helps you to identify an atom. So first, an atom contains a nucleus. Let me just surround this thing. So this atom contains a nucleus. So what is a nucleus? A nucleus is just this round shape you can see here, which contains the positive charges, which are called the protons, and the neutrons, which are the neutral charges. So this is what is contained within the nucleus. So in the nucleus, never forget that we find the positive charges, and then the second thing we have in an atom is orbitals. So these are called orbitals or shells. So here we've got shell number one, and shell number two. So these are called shells or orbitals. So what do these orbitals do in an atom? An orbital carries the negative charges, which are otherwise called the electrons of an atom. Remember that the protons are the positive charges, the neutrons are the neutral charges, and the electrons are the negative charges. So let's reposition them. So the protons and the neutrons stay within the nucleus, this nucleus, and then the orbitals will contain the electrons. So where do the electrons stay? The electrons will be found in the shells surrounding this whole nucleus. So let's look at how do we find the number of electrons of a certain element. So first of all, we've got this thing called the periodic table. So the periodic table of elements contains certain elements with atoms within it. So for example, if we take this element, which is hydrogen, so you can see this is the symbol H. This symbol H helps you to identify as to exactly which element is this, and to identify what is its contents. So let's look at the contents of an element on a periodic table. A periodic table has got a symbol of an element, which has also got the atomic number. So the atomic number just is arranged from 1 up to the last number, which is 118. So from 1 is the hydrogen, or it's just represented by the symbol H on the periodic table. You can see that we've got simple symbols here, which are representing which as to exactly which element do we find this atom in. So we find first, it's got this box structure. As you can see here, I'm just redrawing it here, and it's got this box structure which contains here the symbol of that element, which will also contain the mass of that element. So the mass of hydrogen is 1, although this particular periodic table does not really indicate the number or the mass or the atomic mass. So it indicates the atomic number. This is called the atomic number. So what is the atomic number? So basically, the atomic number is I have already explained exactly that atoms are arranged from 1 up to the last atom, 118. So the first atom, we just see by the atomic number that this atom is in which position in the periodic table. So it's arranged from 1 to 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 118. Okay, so here we find the atomic mass. So the atomic mass is just the mass of an atom. It just tells you exactly how heavy is an atom. So there's an atomic mass, there's an atomic number. So how do we find protons, electrons, and neutrons in that? So first of all, you can see here, let's redraw this structure. You can see here this is hydrogen. This is the symbol of an element as represented in the periodic table. We find the symbol first, we find the atomic number, we find the atomic mass. So here, this is the atomic number. Remember this and never forget. And then this is the symbol of an element, which helps you to identify exactly which element is this. And this is the atomic mass of that element. So it means each atom of hydrogen contains the mass of 1 with that unit, 1 unit. So here, to find the number of protons, so number of protons, how do you find the number of protons? The number of protons is simply equals to the atomic number. The atomic number. So, in other ways, these atoms are just arranged in their number of protons. So if you can see, this is the hydrogen atom. We've got the atomic number 1. It means it has got 1 proton. Right. And then we go next to the number of electrons, which are the negative charges of an atom. Number of electrons. So the number of electrons is also equal to the atomic number. There is no difference there. So it's equal to the atomic number as well. So here we've got the number of protons, the number of electrons, all equated to the atomic number. It means in hydrogen, we've got only 1 electron. We've got only what? 1 electron. So how do we draw this thing? Oh, we still have a shortage. We need to find the number of neutrons. So let's try to find this. So the number of neutrons, how to find the neutrons or the neutral charges? The neutrons or the neutral charges are found by subtracting the mass, which is the atomic mass of an element, subtract the atomic number. So in case of hydrogen, we've got a mass of 1 minus 1. So hydrogen does not have neutrons. So it's got what? 0 neutrons, actually. So it means in a hydrogen atom, we only find the number of protons, the number of electrons, and nothing more than that. So how do you represent this in an atomic diagram? So we simply first draw our nucleus. You can see this is a nucleus. So this is a nucleus, and then you put in your protons and neutrons. So in this case, we've got 0 neutrons. Then we have to put in the number of protons within the nucleus. So it means this atom is not neutrally charged or does not have neutral charges. So we'll have 1 proton and that's all. And then we'll have what? We'll have an orbital. So remember that the orbital is responsible for carrying electrons. The nucleus is responsible for carrying neutrons and protons. Get this straight so that you don't easily forget it. So here, let me just open one space for the electron. So here we'll have what? An electron. So this is the orbital here. So this orbital contains an electron. So remember that the shells or the orbitals contains electrons, the negative charges, while the nucleus contains the positive charges of an atom. So I'm sure you've got good clarity there as to exactly how do you find the number of electrons, the number of protons alongside the number of electrons. So here we go to the next, the capacity of these shells or these orbitals. So capacity of shells. So remember, when we're talking about the shells, we're simply talking about these orbitals. Let me just rewind you back to this diagram. We're talking about these orbitals which are surrounding this nucleus here. So remember that the shells will contain your electrons. So in this case, let's look at the capacity of those shells to hold electrons. So first of all, we've got the nucleus here. We're not really going to draw anything, but then this will represent that the nucleus contains the protons inside it. And then we've got the first shell. So this is the first shell or the first orbital. So here I'm filling in the electrons. You can see this orbital can only contain a maximum of 2. So this first shell, this is 1s. This is the first shell. It can contain only 2 electrons. Remember that these cannot have protons, cannot have neutrons, but only electrons, because the orbital surrounding a nucleus can only contain electrons. So this contains 2 electrons as maximum, and then the next orbital will contain 8 electrons. Right. Eight electrons. So it means that this second shell or this 2s shell will contain 8 electrons maximum. 8 electrons. The first one contains 2, the second one contains 8 electrons. So an easy way not to forget exactly how many electrons does a certain shell contain, you just have to use the formula 2n squared. So 2n squared, what does this exactly mean? So this is a simple way, it's a formula for what? For calculating exactly how many electrons can each orbital hold. So remember the first orbital, this is 1, this is 2. So here, this n represents the orbital number. So this is an equation. This is actually a formula, So here you can see this is the orbital number 1, orbital number 2. So let's prove this formula correct by substituting orbital 1. So it means we're talking about orbital number 1, and then squared, you get 2 times 1 is equals to 2 electrons. So this means orbital number 1 can only hold a maximum of 2 electrons. And then how do you find the maximum number of or the maximum holding capacity of the second shell? You have to say 2 multiplied shell number 2 squared. Then you find 2 squared is 4. 2 multiplied by 4 is equals to 8 electrons contained within the second shell. So never forget this formula for easily finding out exactly how many electrons does each orbital hold. Thank you for watching.
Ángel la ciencia. Evans.